and we'll be having our guest speaker present today for Unity 3D and ChainSafe Gaming.
Okay, I guess I could get started. And thank you everyone for showing up. My name is Kwame. I am a core developer on the ChainSafe Gaming SDK. And I have some slides to start off, and then we'll get into working with the SDK. So I'll just get these slides started. Let me share my screen. Okay. So yeah, so this will be like a multi-part kind of like course on creating blockchain games, and of course using the ChainSafe Gaming SDK. That's what I work on. So a bit about myself. I'm a software developer on the gaming team at ChainSafe, and one of the sole developers working on the ChainSafe Gaming SDK, which we call Web3 Unity. A bit about my background before getting into blockchain games. I worked with EA Mobile, Microsoft Game Studios. Here's kind of a list of some of the games I've worked on. Done contracting also. Curriculum designer and instructor at George Brown and Humber Colleges in Toronto, Canada, where I'm based. How I got into Ethereum in general. In 2014, there was like a Toronto Bitcoin Expo, and they had a hackathon, and that year Ethereum was the hack. So I kind of was fortunate enough to be in the Toronto area, and kind of just been lingering around since then. If you want to get a hold of me on social, I'm at Elijah Nomad on Twitter, and you have my Discord handle there if you want to talk to me about gaming or collaborations or whatever else. My main areas of interest are, of course, in mobile and blockchain game development, distributed systems, and game theory. So just a quick overview of the ChainSafe Gaming SDK, or Web3 Unity. Is it's really meant to make it seamless for developers to be able to just drag and drop these like prefabs that have like pre-configured Web3 components and Web3 functionality built in. So from a game developer's point of view, is that like we're building out games first, and then we're adding these Web3 interactions to the games that we're building out. And that was kind of like a lot of the methodology around Web3 Unity, is that if you needed to like plug in like a coin that was like an ERC20, then there would be a prefab that you could just drag and drop in and change parameters to fit the chain or the need of the prefab that you're kind of like working with. So the three major EIP standards that we work with in the ChainSafe Gaming SDK are the ERC20, ERC721, and the ERC1155. But the gaming SDK itself is flexible enough that you can add in other ERC standards into your games if need be. And as we kind of go through this course, and I'll show you how you can kind of like dig deeper into it. So out of the box, the gaming SDK supports EVM compatible chains. So the kind of the rule of thumb with working with the SDK is that if you can connect MetaMask to the chain that you want to work with, if you can connect it to MetaMask, it's functionally going to work with the SDK. And it has support for IPFS, Filecoin, and we have a product at ChainSafe called ChainSafe Files, which is kind of like our version of like Piana, and we also have ChainSafe Storage too, but I forgot to add that to the slide. And we actually have this was a recent update to the SDK, and a part that I'm kind of pretty proud of is that you can actually create your own in-game marketplaces inside of Unity. So we have like the prefabs and the plumbing to be able to do that. And lastly, we have a marketplace. It's currently in beta, but I'll be showing you guys that also. And you can, create user-generated content for the games that you're playing, and it's great for developers that just want to go out and, create some, 1155s or 721s for their game, and not have to go through like, Rarible or OpenSea. It's designed to work seamlessly with the SDK, and a lot of our users were finding that, if they use like these different, marketplace platforms, that it didn't really work well with games. So we built this tool in order to solve that problem. And you're going to see a link to our GitHub here, and that's where you're going to download the SDK and get started with it. So when you do go there, of course, start the project. Everything that we have is basically free. So people starting the project and being involved in our community is kind of like where we get that reassurance that the stuff that we're building and the stuff that people are using are good. So I'll kind of just go over how most of the people here have a background with Ethereum and some of the standards, but maybe for some people who are still new, they might want to try to think of it of how these particular standards can actually be implemented into games. So we have the ERC 20 standard, and this is basically like a fungible token. So it has fungibility and can be interchanged with another, just like, like a dollar bill. And the majority of like the tokens that we, speculate on, or whatever the case may be, are on Ethereum, that is, are of that ERC 20 standard. In our games, where people are collecting points, this would most likely be like a token, right? Or like a coin that they're using. Most times in blockchain games, we'll call these tickets. That are transferable for the actual token itself. But in my games, the games that I do, where I'm collecting points, I'm usually reimbursing players with a token inside of that like play to earn kind of like game mechanic, right? But this can also be used for as a utility token for purchasing particular items that people have or game developers will have inside of their games, and they're using this token that is a part of the game. So if you kind of look at like games that are built by Gala, where they have like the Town Star token, and you earn this Town Star token, and you use that particular token to level up and buy resources and things like that. And of course, like voting for like DAOs and having your community want to vote on changes to the game or updates that are going to be done, you can use this token as a part of like a DAO for voting. Now the ERC 721, I'm sure as I said before, a lot of people are going to be familiar with these standards and know what they are. So the ERC 721 is a data standard for creating like non-fungible tokens, right? So they are totally unique, right? And can't be interchanged directly for another one, because everything is unique to that. Now, in games, you'll see these more as being like non-fungible avatars, or NFAs, as I like to call them. I don't think there's like a really particular standard for a game character that is of the ERC 721 standard, but I liken them to be like non-fungible avatars. So you buy a character, that character is totally unique, and it's an avatar that is used in the game, right? It can also be used for game items, and you'll see like ERC 721s, and you'll have a bunch of different like loot boxes, or battle axes, or any kind of like components that you would see in your games could definitely be ERC 21. But there's another standard that we are going to look at next that fits that particular niche in games a lot better. And that one is called the ERC 1155. So it basically takes the best of an ERC 20 and an ERC 721, it has this agnosticity of fungibility, and it's a lot more gas efficient. And you can see that why not only would that be good for people who are interacting with your games, but also just in general, anytime we can save gas on contracts and launching them is always a great idea. So if you're looking at like a game where you could buy like say food or health or ammo or things like that, it would be better to have that as an ERC 1155. And you'll see this standard more so in games, because the way that we're thinking of that, we're creating this object, but we're going to have multiples of this same thing. They're not totally unique, but we want a lot of them. So they fit well. And of course, they have the metadata that's associated with it. And that was something that I should have mentioned in the last slide, is that the ERC 721 and 1155s, they have metadata that's associated with it. And you'll get into this in subsequent lectures of creating our metadata, but you'll see this when we check out the marketplace. So there is something called the the blockchain trilemma, right? And Vitalik Buterin, brought this up, where blockchains can have two, but they can't have like all three. And the reason why that we have these layer twos currently right now is because of this particular problem. Some blockchains have been quoted to have solved it. One is Algorand, but a lot of them basically have, like, they will have two parts of this, and one will be basically non-existent, right? So if we look at Ethereum at this current stage, we have the security and the quote unquote decentralization, using a lot of like the Infura and the node providers, can kind of be questionable, but you can download and run your own node. So there is this sense of decentralization with Ethereum, but it's slow, so not great for games. And then you'll have something like Polygon, where it's has a lot of speed. It may have the security, but it's not really decentralized, because a lot of these node providers are of a particular salt. So it's like, well, okay, here we go again, right? And if you go down the list of all these EVM chains and all these layer twos, and you start mapping it out to this trilemma here, we basically have this problem. And with blockchain games, we have the same particular problem, but on the it leads more to the security side, because we have access to the speed, and some of these chains that are on the layer 2 area do have the decentralization, but they might not, they might like lack more on the security side. And there are some chains that are doing well in this area. But for games, a lot of the time when we're building out our games, we're still using a centralized server somewhere, either for positioning in a multiplayer or like a metaverse type of implementation of a game, or for sending out tokens. They're still used at like a centralized server that has an account on it that issues out tokens when you get the high score or whatever like that. So we still have our issues when we're creating blockchain games, but they're warranted just because of the way things currently are. But implementing like zero knowledge proofs and some of these other advanced kind of topics could possibly fix it. So in the blockchain game trilemma, a lot of it is that we still need these centralized entities to like hold an account that has its seed phrase behind a secured server that issues out tokens, and we haven't hit all three. So the same problem that we have with just general blockchain in the blockchain trilemma is also found in the blockchain game trilemma, but just with these added parts that are, if you made games at that level, you would understand that, there's just some things that you just can't decentralize at this point. Okay, so some of the top blockchains for gaming. So Scale is a really awesome blockchain that is out there. I talked about Polygon, and the reason why Polygon is in the mix, even though that there's some of the parts from the last slide are inherent in here, is because it's basically like ETH 2.0 right now. And it's just a really good chain, and it's getting a lot of traction. And I see really good things from Polygon. And Nebula is a new chain that has just come out. It's a scaled gaming hub. It has gasless transactions. And if you guys are interested in finding out more about Nebula, I'll be talking a lot about it. Just because I think that it's going to be the chain, the up and coming chain over 2023 and 2024 to onboard games. And the one thing that's really cool about it is this whole like gaming DAO ecosystem, but it's very, very new. And people on this call are pretty, other than the core team at Nebula, you guys are like the first ones to really know about it. But if you go to chainlist.org and you search for Nebula, you'd be able to like add it to your network, but it's kind of hush hush. Not anymore because this is recorded. Okay, so the current problem with Web2 centralized games and how the ChainSafe Gaming SDK tries to solve this. So let's look at like the history of games. And we're taking into account like web-based, type games here. So we have in Web 1 where you could just basically read. So you would have a game that was on a site, and you just basically played it to your own accord, and that was basically it. And then we got into the Web 2 world where we are right now, still currently in the game world. Where we have this like read and write. You're playing a game, you're writing stuff to a centralized, database, and everybody in that whole game is basically writing to this database and just pulling back this information. Now we're at the third part of this image where we're currently in this, Web3 world, and we have the reads, we have the writes. Which are, maybe still, on the centralized part, but a lot more games with it being, gasless and a lot faster and cheaper. We're seeing that like a lot of the games are moving to this on-chain games where, the high scores are online, the metadata for the non-fungible avatars or the NFTs are being written on chain. And the one thing that is definitely different when we're moving into this Web3 space, and something that gamers haven't really taken advantage of, is that we actually own all of our game assets. If a server goes down for whatever reason, our characters, what they've done in the game, the assets that they hold, and all this stuff is on chain. And that's like one of the beauties of this, is that when we're investing into the games in the Web3 space, we actually still retain ownership of our stuff, and that's awesome, right? Okay. So how does ChainSafe fix this particular problem? Well, as I mentioned earlier, we have like a bunch of prefabs for interacting with EVM blockchains. That's number one. Number two, it's made to work with Unity 3D. So there is a treasure trove of game developers who have built games out in Unity and can easily attach these Web3 components to their pre-existing games. So it really has that, once this is starting to snowball and that contagion effect starts to catch on with the on-chain gaming, we're going to have like a ton of really, really awesome, games that are made in Unity, they're going to be able to just drag and drop these components and add Web3 enabled parts to their game. And some people from the gaming community might not like that, but once this whole, you have to buy an NFT in order to play the game and all that jazz is done with, and I'm starting to see that people are moving away from it. Gamers will embrace it. I know right now a lot of gamers think of NFTs and games as being like a cash grab, and on record, I think some of them are, but a lot of the really good games are moving past that and using the utility of the blockchain and that self-sovereignty of ownership for their game players as being the driving force of why they're implementing blockchain. And I think that this will continue. It also has support for mobile and desktop. So you can create mobile and desktop blockchain-based games with the SDK. And of course, WebGL. And this is where we see probably like 90% of the people who use our game, our gaming SDK, will use it for the web. But we're actually starting to see people build out, mobile games and actually push these to like the Android App Store. And that was really cool. We do kind of have going back to this whole, the blockchain game Trilemma that we were talking about. It currently runs by an API. I'm currently working on V2 of the SDK, and V2 of the SDK will be totally decentralized. And I'm hoping by the time we get to the end of this 4-part series, that this will actually, be non-existent. You'll actually probably be the first ones to see the purely decentralized version of the ChainSafe Gaming SDK. We have easy to use and follow documentation, and we have a really active Discord community. And that's one of the highlights of working on this thing and actually seeing people who start using the SDK and then publish their games and then get funding for it, and it's really cool. Kind of like the one of the highlights of working on this thing is seeing people get to that next level. So what makes up the ChainSafe Gaming SDK ecosystem? As I mentioned before, we have these, prefabs that allow you to, interact with EVM blockchains. It's made with Unity 3 developers in mind, which has like a huge community. It's like the second biggest, gaming engine out there other than Unreal. It has mobile and desktop, and an easy to use API with plans for decentralization coming in V2. Set to be at the end of Q4, but I've made some really good progress over the last couple of weeks on it. We have an active Discord, dedicated marketplace for creating game assets, work on Goerli, testnet, and Ethereum. And we are planning to extend this to more and more chains. And we really look to our community to tell us like what chains we need to support next. And it's easy to create marketplaces using pre-configured Unity prefabs. And after we kind of get everything installed, I'll go through and show you guys how that stuff works. Okay, so now let's get into showing how this is done.
Okay, great. So now that you have a project set up, the first thing you're going to need to do here is you're going to download and install the Web3 Unity package that you've downloaded. So you can get this at github.com/chainsafe. Click on Web3 Unity, and then you're going to see that the current release is 1.5.0. Click on the releases, and then just download the web3.unity package. Now you just need to import. Now they have all the assemblies, we can quickly go over the packages and what they do. So in Web3 Unity, we have our documentation. This will just We'll give you, basic information on how to, install, use the Minter, marketplaces, and anything like that. And then we have our prefabs, and these are the pre-configured components that just have pre-built functionality. So we have them for ERC20. You can see all the basic, getting the balanced name of tokens. ERC721, the same. We have some other implementations for getting all 721s, working with the URI of a 721. The same for the 1155s, also similar functionality. And then we have our EVM, calls, custom calls, working with the transaction status. All of our Minter components. So you can see here, you can get with a voucher, you can list items to our marketplaces, minting with the voucher, minting with web, with just the web, and then getting a receipt and then minting out. So definitely tons of all the different things you need to know. But for just the simple installation in this tutorial guide, we'll just make sure that everything is configured properly. So we'll click on scenes here, and we'll work in this sample scene. And the first thing I'm just going to do is create a test script. And I'm just going to call this player account. And what I'm going to do is add a UI component, because the purpose of this installation step is just to make sure that the Web3 Unity and Unity itself are communicating properly. So we'll click on a UI element. I'm just going to use a legacy text element, and I'm just going to call this player account. And I can see it down here, but I want to just position it better. So I'm just going to click on F to focus in on that UI element, and then I'll just move this into an area that makes more sense for what I'm doing. Probably extend this to be the player UI component, but this will just serve this purpose for now. And I'll just make it a bit bigger, and also I'll center it. Okay, and I'm not too concerned about the default text, but you just have it be blank if you wanted, right? But I'll just put account for now. Okay, so let's edit this player account script so that we can get the player's public account when they log in through MetaMask or another wallet. So just let this open this up. Okay, so now that this is open, I know for sure we're going to need a Unity engine UI, and then we're going to have a public text property, and we'll just call this player account. And my editor's trying to catch up to me here by processing the files. But I know for sure here I'm going to need access to the player account. And within the player account, it has a text property. And then from the player prefs, get string, there's a property called account, and that stores the public account of the player once they go through the login process. So this is a pretty simple script, but it's a good test script to do especially if you're new to using the SDK. So I'm going to go back here, and what I'm going to do is select the account property, and then I'm going to add a component, and I'll just call this player account, and then drag the text property into the player account. So now we need to select the order in which the build process is going to go. So we'll go into build settings, and it's going to remove this. Yours will be blank. Should be like this if it's, you know, the first time you're using it. And within Web3 Unity, we're going to have scenes, and you're going to see that you have a wallet scene and a web login scene. The wallet login is for desktop and mobile builds, and if you want to do like quick iterations inside the editor. And another one is the web login. Now the web login, of course, is just for WebGL. So you're going to have to take this into account if you're using web login, because there's certain things that you use with web logging and certain things you use with web login. But as you kind of go through, you'll see that they're basically the same, but just some class methods are different, but the API for it is exactly the same. So we're going to use the wallet login, and then we're going to take the sample scene, and then this is going to be like the secondary scene. So after we've logged in, authenticated the user, we'll go to the sample scene. Okay, so next thing we need to do is just click on the wallet login. We'll save this. And now we can test this out. So I'm going to click off the Remember Me. Click play first. And just uncheck the Remember Me. Click on Login. Okay, I'll sign. I'm going to copy that signature to clipboard. Okay, so we've logged in, you know, and this is the same account that's logged in right currently. Let me see, 229. We have 229 here. Okay, so the next thing that we're going to need to do is let's see how we can access our marketplace and like create an NFT and then display that in game. So we'll go into the scenes and we'll say our sample scene. And here I'm just going to like right click and I'm going to create a cube. So let's select a 3D object. I'm going to create a cube and I'll just call this NFT. Okay, we have our NFT here. And then in this position, we just want to zero this out. So say 0, 0, 0. And then for the scale, we'll say like 3, 3, 3. Yeah, that's all right. I know this kind of looks like awkward. So okay, great. Okay, so that's good. So what's the next thing that we want to do here? So let's bring up our browser, and I'm just going to call like ChainSafe Marketplace. And want to connect wallet, but we're going to want to go to an account that actually has some Gorilla ETH on it. Okay, this is like the default account that I use for this. So now that you've reached marketplace.chainsafe.io, you're going to have to connect your wallet. And then now you can actually create. So go to create, and this is Ethereum Gorilla. This is the token type, and the supply is 1. And we'll just call this like, this is, let's say, background. Some kind of like background asset. So I'm just gonna drag this in. It's like checkered background image, and no additional properties for this. It can be, you can do that if you want, but just for the sake of it, we just want this this NFT. So we're going to create this NFT, and then sign. Okay, we're going to mint out this NFT. Click on confirm. Okay, so just got confirmation on that. And cool. So now we have the opportunity. We could list it for sale in here, but we also can do this inside of the SDK. And that's kind of what I'm going to show now. So what we're going to do here is that we're going to create a new file, and we're going to call this, we'll just call it like NFT. Okay, and then we're going to need to edit this script. Okay, so one thing that we should do here is that inside of our checkered background, we can view this technical data. So let's click on the data, and there's some important information. This is going to be information that we're going to need to plug into the SDK in order to access this token. And this is what we're going to need in order to define how the gaming SDK works with this. Okay, so I'm going to copy this, and then I'm going to go JSON to C#. And then I'm going to, paste in this information. And this is basically what I'm working with. So this is the model object. Okay, so this is the model object that we get from our image here. So this is the first part that we're going to need. So I'm just going to basically just copy this, add it in, and I'll just call this response. Okay. And inside of our public start, I'm just going to say string chain. This is equal to Ethereum. And then we have the string network. And this is equal to Goerli. And then we'll have the string contract. I'll just stub this in for now. And then string token ID. And this is going to be the token ID of what we saw. So I'm just going to, don't have that currently, but we'll just open our marketplace, and then we see here that we have the contract, so we'll just copy this and paste that into here. And then we have the token ID, so just take the token ID and paste it in here. And now we can call, we want to fetch the URI from the chain. So we're going to say string URI equals URI, sorry, await. We're going to say ERC 1155 URI, and then we're going to say chain we're going to say network contract and token ID. Okay, so it's complaining here, and because this is an asynchronous operation, so the start needs to be async also. So we'll just put that in there. Okay. And now we should be able to just get, so say debug.log and then URI, and then we say plus the URI. Okay, we'll save that, minimize this, and make sure this will add the component. This will be NFT, and this just basically prints on start, so we should get some data in the console. So we'll select that, and you can see here that we have the URI. All right, so this is great. So let's go back to our script and start filling out some of the other parts for it. So now that we have that, there are instances where if we just get like the IPFS : // we might just get IPFS, and we need to handle that. So what we're going to do here is that we're just going to say if the URI starts with, and the clause here is that if it starts with like an IPFS //, right? What we want to do is say that the URI is equal to URI.replace the IPFS : // with the HTTPS / IPFS .io /IPFS, and just make sure that everything's good there. And okay, so that's good. So the next thing that we want to do here is that we want to fetch the JSON from the URI. So it's similar, but now we just need to get that data that's inside of it and parse that out. So we'll do a Unity web request. We'll just call this web request. And then we have our Unity web request. And we want to get the URI that we got now. And then we will await the web request, send request. And now we want to get that response data. So we have our response that we've modeled up at the top, and we want to get a data object from this. So we're going to say our called JSON convert. This is from Newtonsoft, and we want to deserialize the response. And what this basically means is that we want to like the data that's come back from the JSON, we're modeling it in this model object, and now we want to take that data out of it and just like a normal string so we can actually mess around with it. But it seems to have done a couple of like extra things here that we don't need. So I'm just going to say this is the response, and then in our parentheses now we can say system.text in the text, and that's not great, not an exception. just system. All right, dot text, dot encoding, and UTF-8. And now we want to get string and the web request. Let's download handler. Data. Okay, we can stretch this out a bit. Okay, so now that we have that, we can parse the JSON and get the image. Let's say parse JSON and get image. Let's say string image URI is equal to data dot image. Now, this is kind of like another operation that could be cleaned up, but just for this demonstration, we'll just say that if it starts with this IPFS, and we have it above here, and we're just saying that the image URI, we'll just copy and paste this into place. Okay, so we're good there. And now we want to fetch the image. So we'll fetch image and display. So we have our Unity web request, texture request equals Unity request texture. Dot get texture and the image URI. So this is just like convenience that we get from Unity. And now we will await the texture request, send that web request. And now with this game object, we want to get a component from it. And the component we want to get is its renderer. And now that we have the renderer of this game object, we want to access its material and its main texture, because we want to apply this image that we're getting from our own web request onto the actual onto the game object's main material. So we're going to say download handler texture, and then the texture texture request, download handler dot texture. Okay, good. So basically what's happening here is that now that we've parsed the JSON out, we can now get the IPFS image of where this image is basically hosted. If it conforms or checks for these things, then we kind of swap it out, and then apply the image that is from our NFT onto the game object. Okay, so let's we have our image here. We just want to make sure, and the one thing I'm going to do here is that it's just not to make it assume that it is. I'm going to just say in here Let's say public game object, make it explicit. Okay, and I'll just pass this in here. Okay, and I have to do it again. Okay, and now we will click on play. And there we go. And now we have our NFT image, and it's applied onto a game object.